Hi everyone, Gustavo here from Divergence AI. I want to show you a couple of our latest features that we're releasing this week with the new version of our HFSS Copilot. These features are designed to help those of you that are building antenna arrays work through the manual labor of steering arrays and extracting data from something that takes hours to something that you can automate with our system in minutes. So let me show you here that I have this array of 5 elements and it's already loaded up into our application here. To start, this is new. We can plot the beam. Our agents now have the ability to actually connect to the array and very quickly get the beam pattern. The next thing that I want to show you is that you can steer this array. So you can say steer the beam 10 degrees and plot it. Again, our agents have the tools to actually set the phases and amplitudes into the array and plot it again. So here you go. This is the new beam. And notice that we didn't have to add the details of the array geometry in order to steer the beam. Our agents automatically can get that by looking at the coordinates of the ports in the design. So of course, this is something that you can do by hand, but if you have to do it many times, that is very time consuming. And so you can just ask our system. So for example, you say steer the beam from 0 to 30 degrees with a step size of 10 degrees and plot the beams along the way. Now, this is a more complex request, but our system will create the code to do it. So right now it creates the pattern at 0. Then it will step through 0, 10, 20, and 30. All right, now it's steered at 10. Here you go. And of course, you could have along the way asked to extract this data into CSV or compute the side lobes or anything that you wanted. Here we are at 20 degrees. And we should see finally the beam steer at 30 degrees and the plot. Perfect. Now notice that the beam side lobes are looking a little bit crazy here. So this is a good segue to show you the next feature that we have. So let's steer this back, the beam back to 0. And let's apply a tapering so that the side lobes are controls, and apply a Chebyshev tapering, then plot the beam again. As you can see, we have the ability to apply an amplitude tapering along the array elements, and we have several options that are pre-programmed. So Chebyshev, a uniform, of course, Taylor, cosine, triangular, binomial, and we'll be working on later on adding a general tapering that a user might want to do. So here we go. We have our beam steered at the center with a Chebyshev tapering, and you can see how the side lobes are minimized here. The last thing that I want to show is that we can actually measure the side lobe level, and our system again knows how to get that inside here. So here you go. The side lobe level is minus 33 dBs, and I'm sure the agents will also give you a summary here. So in summary, you have the ability to steer the beams, extract the data from it, create plots, and ask the system to do any kind of sequential sweep that you want while you're extracting the information that you want, all in minutes instead of hours. So if you're interested to try it, please DM me or comment below, or if you have any feedback, I'll be super happy to hear all of it. Looking forward for you to try it. Thank you so much.